Okay, class, this is just a very quick progress check review for quarter two. The progress check is tomorrow. I'm on page 1. And remember that I asked you all to memorize all of the i's from I to I to the fourth, mostly because I squared and I to the fourth have real numbers. So if I'm looking at 1a and it's talking about addition, remember I'm going to write both functions that are in parentheses all together, and then I'm just going to be combining like terms. Since there's no negative sign between the two, there will be no sign changes. So 2 is going to combine with 1, and 3i is going to combine with negative 6i. I end up with 3 minus 3i, and since there's still an I, it's a non-real solution. Letter E, skipping over to the right. I do have a negative sign in the middle, which is the indication to change all the signs in the expression behind it. So negative 5 becomes positive 5. Negative 3i becomes positive 3i. And again, I'm going to combine like terms. Remember with the I, where you don't see a coefficient, it is going to be 1i. So 1i plus 3i is 4i, and 5 minus 4 is 1. Final answer also has an I, non-real solution. On to letter B. I squared and I squared comes from our memorization list. I squared can also be substituted with negative 1, and since we repeat the addition of I squared, adding two integers results in an integer answer. That integer answer has no I, so this answer is real. Letter F. This shows two parentheses with no sign between them, indicating that it is multiplication. All of the arrows you see here are me doing FOIL, or as my tutoring student called it, extreme factoring or extreme distribution. So I'm going to multiply 2 times 2 for 4. 2 times negative 4i is negative 8i. 4i times positive 2 is positive 8i. And 4i times negative 4i is negative 16i squared. I squared again goes back to our memorized list. I squared is going to be substituted with negative 1. And when I substitute that with negative 1, it becomes negative 16 times negative 1 for positive 16, and positive 4 plus 16 is 20, also a real solution. Page 2 is combining functions. Remember, we are going to ignore this x in every problem and pay only attention to the sign that tells us what to do with the two functions. F and G is our function bank on the top. F is going to be x squared minus 3x minus 4, and in A it tells us to add those functions. So x squared minus 3x minus 4 is added to 1x squared minus 2x plus 6. Because the sign between them is positive, there are no sign changes. 1x squared plus 1x squared is 2x squared. Remember, don't add the exponents in addition. Negative 3x and negative 2x is negative 5x, and then negative 4 plus 6 is positive 2. Letter B asks us to do subtraction between the two expressions. So x squared minus 3x minus 4 gets written as is. The negative sign in front of function g is a sign changer. So everything that's positive becomes negative. Everything that's negative becomes positive. Positive x squared becomes negative x squared. Negative 2x becomes positive 2x. And positive 6 becomes negative 6. Again, we are combining like terms. Our resulting answer is negative x negative x minus 10. This would be page 3. Page 3 asks us to look at the graphs and talk about whether the solutions are either real or non-real. Now remember, these are all quadratics, so we are expecting either one real solution, two real solutions, or two non-real solutions, depending on how many times our quadratic hits the x-axis. So here is the x-axis in each function, and I am looking for the intersections with the x-axis. Here it's 2, so this is two real solutions. Again, two real solutions. This function here does not hit the x-axis, so I'm going to say two non-real solutions because there are no x-intercepts. In letter E, across that x-axis are two x-intercepts for two real solutions. In letter C, the vertex is the only part that hits the x-axis. One real solution, but if you remember when I have a touch and turn, the multiplicity is 2. So that solution, and it looks like it's negative 2, is going to appear 2 times. So it's really two solutions or multiplicity of 2 for one real solution. In letter F, again, this quadratic does not hit the x-axis, so there are no real solutions. Next page is a graph that has lots of different multiplicities, and what we're going to pay attention to is how each function crosses the x-axis. Here is the part of the function going through negative 3. Notice how it was a straight line through negative 3. That would make a multiplicity of 1. The reason I am adding these up is because question A asks us for the degree. So I need to add the multiplicities or add the exponents. X plus 3 does not have an exponent, so of course you're going to put a 1 there. So 1 plus 3 plus 2 is 6. So that's the answer to A. Our multiplicities are also asked in question C. At negative 1, remember that when our graph goes close to the x-intercept, kind of turns and keeps going, that's going to indicate a multiplicity of 3. So this solution, negative 1, appears 3 times. Over here, with the solution equal to 2, I touched and turned around with my curve. That means a multiplicity of 2. Letter C asks what's the multiplicity of the 0. Remember, 0 is x-intercept. And at x equals 2, that was a touch and turn, multiplicity of 2. Our x-intercepts, they just want us to name them. So give the x value, negative 3, not negative 2, sorry. Negative 1 and positive 2 in list form. And behavior, both arrows face up towards positive infinity. So as we approach from the left, y goes, or g of x goes to positive infinity. As we go to the right, towards x is positive infinity, our g of x also goes to positive infinity. Number 6 on the next page gives us another polynomial with most or all of the exponents missing. So we are going to highlight them because we are probably going to be asked the degree of the equation, and we are asked the degree where there are no exponents after each parentheses. We're going to put a 1. We're going to add them together, and the degree of that equation is 3. 3 is an odd number, and it's positive in front of the equation. So remember, I'm always going to compare the end behavior to a positive sloped line, because a line is x to the first power, 1 is also odd. So for my end behavior, I can expect the left end to go down towards negative infinity, and the right side, as x approaches positive infinity, for our function also to go to positive infinity. For B, I am going to be using my equation to solve for all of my x values, which are my zeros. Remember, x-intercept, solution, and roots all mean the same thing. Down on the bottom, you can see here that I am solving for x plus 3, x plus 7, and x minus 2. I'm setting each of these factors equal to 0 and solving. I get x plus 3 equals 0, x is negative 3, x is negative 7, x is positive 2. So I'm going to list my zeros, solutions, or x-intercepts here, and I'm going to graph those 3 points that I solved for. Now is the time to use the end behavior that is similar to my positive slope line to fill out what happens on the end on the right and what happens on the end on the left. You can see that these kind of mimic what we've done with the line. Now, since all of our multiplicities are 1, remember, that looks like the graph going straight through the point, turning around, going through the next point because that multiplicity is 1, and then connecting with our last intercept. Remember, that happens because all of my exponents are 1 for each factor. Now, what I need down here is my y-intercept. In my calculator, I can put g of x, and then I can put the entire function in y1, and then I can tell the calculator, using the trace button, tell me what happens when x equals 0. The calculator will tell you the y-intercept is negative 84, and so you just need to mark it on the y-axis. Sorry, this is the y-axis, and you need to label it negative 84. I don't know if I skipped one. Okay, to number 8, it says find the solution and identify as real or non-real. I'm going to focus mostly on letter E below because this is a multi-step solving problem. Remember, the goal is to get x by itself. I do that first by peeling away the furthest number from x, that is negative 12. To move it to the right, I'm going to add 12 to both sides. So now I have 12 equals 3 times x minus 4 squared. Dividing both sides by 3 finally gets x minus 4 squared by itself, and 12 divided by 3 is 4. To get rid of a square, I do square root of both sides. When I do that, x minus 4 is finally free, and because this is a quadratic with 2 solutions, I make sure I do plus and minus 2. Now, I still have to get x by itself. I do that by adding 4 to both sides. Remember, since both parts are real, I need to separate it into 4 plus 2 equals 6, and then of course one of my solutions was negative 2, and so I'm going to be adding 4 to negative 2 to get positive 2. The instructions say label as real or non-real. Both are real because these are integer answers with no I.